Alright, now that you have solved the white cross, the next step is to solve the four corners so that each corner on the top is going to be white, which of course will now make it so that the entire top of the cube, the upper face, is going to be completely white. And at this point you are going to have 7 options. Now don't let all of these 7 options intimidate you. However, I will tell you that maybe after you have solved the cube, one way to get faster at solving the cube is to now look at, identify which case it is, and you will memorize 7 separate algorithms to solve each one of these cases. That'll be later, but in this step I'm going to teach you one algorithm that you can use to solve all of them. The only challenge is that on some of these cases you have to perform the algorithm twice. And before I demonstrate that to you, I just want to help you to identify these different cases. You have these 2 cases which are similar, and what you have is you have one white sticker only that is on the top. The other 3 are not. Now these 2 cases are similar, where you have 2 white stickers on one side that are not up. I should say 2 white stickers that are up over here, and the other 2 that are not white. And the reason these are different is that one of these, the white stickers, are on the front, like headlights, and they call this case the headlights. This one, the white stickers are on the side. One is on this side and one is on this side, so they're over here. And this one kind of looks like a chameleon, because the chameleon's eyes are facing outward. This one is kind of all by itself. You have only 2 white stickers that are up. The other 2 white stickers are diagonal from each other. And then the last 2 cases are also similar in that you have all 4 stickers are not white. And yes, these 2 are different. If you look at it like this, they look the same. But if you turn this one 180 degrees, you will see that it has headlights on both sides. Okay, so this one is what they call symmetrical. This one, however, if you turn it around, you will see that there are not headlights, but the white stickers are on the side. So this one is asymmetrical. Okay, so like I said, you don't have to be intimidated by all of these, because I'm going to teach you one algorithm, and that one algorithm will solve these 2 cases directly. And then I will show you how to use that algorithm on these. So when we get to these, you will perform the same algorithm to first get it to look like this. Then you will repeat the algorithm again to solve the cube. So let's set these aside for now and just look at these 2. I didn't point out, but there is a difference between these 2 cases. In this case here, you'll notice that the white stickers are always on the right. If I look at this, it's not on the left, it's on the right. It's on the right here, here, and here. This one, on the other case, the white sticker's on the left, here, 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 and then of course on this one the white sticker is on the top. So if you haven't already guessed, this algorithm is going to have a right-hand version and a left-hand version. And to hold the cube properly, what you want to do is you want to make sure that the 2 corners in the back are not white stickers on top, and that you have a white piece facing you. So you can see this in this case, this is the proper way to hold the cube. Okay, so now I need to orient this cube similarly. Okay, so if I put the 2 corners in the back that don't have white, but remember also the other condition is I have to be able to see the white on the front. So I have to, instead of putting these 2 in the back, I'm going to put these 2 in the back. So I turn the cube this way, and I can now see the white sticker on the front. So that's actually the first step, is you want to orient the cube in that fashion, where 2 stickers on the back are not white and you can see a white sticker on the front. If the white sticker is on the right hand, you will use the right hand rule, the right hand algorithm. If the sticker is on the left, you will use the left hand. So let me show you the right hand algorithm first, and then I will show you the left hand version, and then I will go to the other cases to show you how to use that same algorithm so that all of these 5 cases now will look like one of these 2 cases. So here we go. The yellow cross is on the bottom. I'm holding the cube properly. This kind of forms an L, or an upside down L, if you can look at it that way. Alright, so one way to help you remember this algorithm is that you only have to use one hand. You don't have to use this hand to turn any of the layers. And if you were using the right hand version, you are going to use your right hand to rotate this piece, or this face, the right face, and you will use your index finger to rotate the top. Okay? And another way to remember this is that the top is always going to be rotating in the same direction. So I'm never going to use this index finger to turn it the opposite direction. Okay? So here we go. The first 4 moves are very similar to the Ruru that I taught you in the previous step. You will do R, U, R prime, but instead of doing the U prime, you have to use this index finger again to turn that up face in the clockwise direction. Remember, I said it always goes in the same direction. So that's almost like the Ruru. Then you will repeat it again, very similar. You will do R, but this time you do the up 2 times. 1, 2, and back down. Let me just show it to you again a little bit faster. So, and the way that I taught my children how to do this is they would say this as they were going through it. They would say up to the front, down to the front, up to the front 2 times, down. So this is the left hand version. Once again, I will use my left hand only. My right hand only stabilizes the cube. The first 4 moves are similar to the Ruru, but on the last move I don't rotate the up layer in the opposite direction. So R, U, R prime, there we go, then up 2 times, and then back down. And you can practice this move over and over again. You will notice that if I do it with my right hand, let me do the right hand algorithm. Now you will see that I've messed up the top, but I need to use the left hand version to fix it. So you can practice that algorithm over and over again. So now I'll start with my left one. So I did that and I messed it up. To fix it again, I have to use my right hand version. Another way that you can perform this algorithm that might make it easier, in fact you can perform it in such a way that you don't have to take your right hand off the cube, or almost not at all. And it might help you to remember. So I'm going to show you a new way to do it. It's the same moves, but I'm moving my hand differently. I'm using what they call finger tricks. I'll take my pinchers, okay, and I'll put them here. I turn it up. I use my index finger to turn the upper layer. I fix my pinchers. Up to this point, I've not had to take my hand off the cube. Now, instead of turning my hand like this to turn the upper, I'll leave my pinchers here where they were, but I'll use this index finger to push the upper layer clockwise. Now I just move my pinchers back and I repeat the process again. And this time I need to turn the upper layer 2 times. 1, and I just follow it around, and then I bring that back down. So let me do it faster so you can see it a little bit better. then you have the left-hand version also. So to fix it, I can use the left-hand version. So that's the right-hand version and the left-hand version to fix the white top. So once again, now, what do we do about these cases where we do not have three non-white pieces on the top? So what you have to do is you have to perform that algorithm once on each of these cases to get the cube like this. And let me just point out an observation that maybe you already made. Is when you go back to these two cases, where you have the right-hand version and the left-hand version. This one, there's some stickers on the right and the left. When I perform the right-hand version here, what I'm actually doing is I'm turning these three pieces clockwise. The three pieces that are not white are getting turned clockwise. I see this piece, if I twist it like this clockwise, it'll put the white on the top. And likewise for this piece is turning clockwise, so the white is on the top. And then finally the third piece is being turned clockwise. This piece stays white. So you'll see that as I'm performing this algorithm, these three pieces are turning clockwise. And don't need to show you that. So keep that in mind now as we pull out these cubes. So in the case of the headlights, you can see that if I hold the cube correctly, if I hold it like this and I rotate this and this and this, these three pieces clockwise, this one will become white, these two will become non-white, this one is also not going to be white. So in this case, this one will be white and those three will not be white. So if I hold the cube like this, now there's only one correct way to hold the cube. If I hold the cube this way and I perform that algorithm with the right hand version, this will be orange, this will become red, this one will become red. So you'll find out that all four pieces, all four corner pieces are not going to be non-white. All four will be non-white, which would match one of those two cases. We don't want that. But if we hold the cube like this and we do the right hand version, now you see that I've taken that case where I had the headlights and I have converted it into the left-hand version. And then you would follow the same process for these four. You will first hold the cube and then you will identify which three pieces can be turned clockwise in order to get it so that it will match one of those two cases. Okay, so if I hold the cube like this, these three pieces will be turned clockwise. So that'll be red on top, blue on top, and white on top. This one will stay the same. So non-white, non-white, white, non-white. And once again, now we have it to where it matches the left-hand case. And you just solve it like that. For the one with the diagonal non-whites, if I hold it like this, you'll see that this piece will become red, this piece will become white on top, and this piece will be green. This one will stay the same. Okay, so I hold the cube like this and I perform the right hand algorithm. Okay, once again, now it matches this case. So I'll use my left-hand algorithm, and we've solved that one. In this case, it looks like I have to hold the cube like this, because this one will turn clockwise, so this one will become orange, this one will become white, this one will become green, this one will stay blue. So I turn the cube back, so it'll be, this one will be blue, orange, white, green. Okay, so I'll have one white corner piece. So now it matches the right-hand case. There you have it. And finally, this one. It looks like if I hold the cube like this, and it'll rotate these three pieces clockwise. So this one will become white on top, this one will become orange, this corner will become blue, and then the last one does not rotate. So it'll be green, white, orange, blue. So we'll have one white corner piece